In this first of three videos that cover aspects of geometallurgy, this video will focus on the importance of understanding the mineral makeup of an ore body and how not appreciating changes in the mineralogy may affect the understanding of processing and the application of an appropriate flow sheet. Now, we're all familiar with the concept of grade and tons, but what is often overlooked is the importance of getting an appreciable understanding of the basic mineralogy of your ore body and how this may affect recoveries and processing once in operation. The vast majority of mineral processing plants, and indeed operations as a whole, quote the grade of economic elements in both the ore body and their journeys through the processing plant. However, mineral processing plants are, by and large, set up to recover minerals and not elements or grades. So why then is it important to understand the mineral makeup of the ore body? Now, this only applies to certain ore bodies, certain commodities, and indeed certain process methodologies. However, with the increasing complexity of present and future deposits and techniques to process ore bodies economically, this topic is becoming more and more important. Changes in mineralogy, whether changing mineral species, alteration of minerals, whether that's ore or gangue, physical or chemical changes, they can all have a huge impact on the plant's ability to recover ore minerals and to produce on-spec mineral concentrate. Now, changes in mineralogy can affect chemical properties, but also physical properties, for example, friability, hardness, or density. And minerals are often not what are described in textbooks and are often complex in nature. The chemistry may vary along a solid solution series or may simply incorporate deleterious elements in a lattice after undergoing alteration or weathering. Simply relying on the textbook description of the mineral or commodity in question is simply not enough, and this can have disastrous consequences when in operations. Recoveries may be down, and concentrate grade and tons may be down on plan. Ultimately, these all significantly impact project economics, and in many cases can be rectified by having a sure understanding of the minerals that make up the rock that is being processed. So what can be done to mitigate against this happening? Well, the first and most important aspect is to understand the minerals that comprise the ore body in question, from a very early stage of the project. Identifying early on what minerals or minerals host the commodity in question, and from there exploring the various processing routes that are applicable. Secondly, once you have a basic understanding of the mineral makeup, it's important to start building up a mineralogical database. This should be done early on in exploration or resource definition and can be achieved on a fairly low sample frequency. This is best done from diamond drill core samples, but can also be achieved from RC or percussive techniques. Ultimately, it depends on the mineral information you want to get out of the data, be it simple modal mineralogy that might be gained from XRD, or more precise methods such as GramScan. It's an exercise of generating data to inform decisions as to processing routes, as well as to red flag anything in the mineral makeup of the ore body that may make it potentially inviable as a prospect or a project. Finally, as the project progresses and more is learnt about the geology of the ore body, it's important to start building up a more detailed picture of the minerals and the mineral species and any alterations that are present. However, this should only be carried out if there are proven knock-on effects to downstream processing. Now, this can be achieved through routine data collection from any metallurgical test work that is being carried out from an early stage. And this will identify where minerals or mineral species are adversely affecting processing performance. But it's also important to then link this in with the geology and to continue to build up that drill hole mineral database with our increasing resolution and data quality. By PFS or FS stage, geometallurgical domaining may be taking form, and it's important to generate sufficient mineralogical data as dictated by those important geomet domains. Now, once in operation, it may be the case that mineralogical data is required as part of grade control, and it's important to continue this process to enable the operation to maximise recoveries, grades, and therefore profits.